There is water at the bottom of the ocean that is hotter than 400 degrees Celsius and it refuses to boil. Not because of some strange new physics. Because the pressure down there is so crushing, around 250 times what you feel on the surface, that water cannot physically transition into steam. It just sits there, superheated, liquid, and chemically aggressive in ways that make battery acid look like a gentle rinse. That is the world inside a hydrothermal vent. And if you somehow survived the pressure and the heat, the chemistry alone would take you apart molecule by molecule in ways that are genuinely hard to believe are real. Let us raise the stakes immediately. These vents are not rare geological oddities. They snake along mid-ocean ridges for tens of thousands of kilometers. They pump out more dissolved minerals in a single year than all the world's rivers combined. And they almost certainly represent the exact environment where life on Earth first began. So understanding what would destroy you inside one is also understanding what created everything alive on this planet. That tension, between destruction and creation, is the story here. First, the pressure. You reach the seafloor at around 2,500 meters depth near most active hydrothermal vents. At that depth, the pressure is roughly 250 atmospheres. Every square centimeter of your body would experience a force equivalent to a small car sitting on it. Your lungs would collapse instantly. The nitrogen in your blood would compress and then, if you ascended too fast, bubble out violently. But forget ascent. You are not getting that far. Now here is where the chemistry becomes genuinely nightmarish. That superheated water is not just hot. It has been circulating through kilometers of volcanic rock. During that journey it picks up hydrogen sulfide, methane, iron, copper, zinc, and a collection of heavy metals that reads like a periodic table of things your body has no defense against. When this fluid shoots out of the vent at speeds up to 2 meters per second, it immediately hits near freezing deep ocean water. The temperature differential is sometimes 350 degrees Celsius across a distance of just a few centimeters. That is one of the steepest thermal gradients anywhere on Earth. That gradient is what creates the black smoke. The dissolved minerals precipitate instantly when the hot fluid contacts cold water. Iron sulfide particles, each 1 nanometers across, form those iconic black plumes. They look like smoke, but they are actually a continuous mineral precipitation event happening at a rate fast enough to build chimneys that can grow a meter in a single week. Now put yourself into that fluid. Your skin, which handles a very narrow pH range between about 4 and 9, would immediately encounter water with a pH as low as 2. That is the acidity of stomach acid. Your outer layer of skin cells would begin hydrolyzing. Proteins denature. Peptide bonds that hold amino acids together break apart under extreme heat and acidity simultaneously. You would not burn. You would dissolve. The distinction matters because burning is oxidation, a fire-based process. What the vent does is hydrolysis, using water itself as the weapon. Water becomes the solvent that dismantles you. If this is making reality feel genuinely strange to you, subscribe right now. This channel covers the science that textbooks skip because they are too worried about making it accessible. We are not worried about that. We are worried about making it true. Here is the second layer that reframes everything. The same hydrolysis chemistry that would destroy your proteins is the chemistry that some organisms have weaponized to thrive. Vent microbes called thermophiles and hyperthermophiles live at temperatures above 120 degrees Celsius. Their proteins are built differently. They use extra chemical bonds called disulfide bridges and they pack their protein structures so tightly that even aggressive hydrolysis cannot find a foothold. One organism, Pyrolobus fumari, reproduces best at 113 degrees Celsius. It stops growing when cooled to 90 degrees. Cooling is its version of freezing. These organisms also deal with the hydrogen sulfide that would poison you within seconds. Hydrogen sulfide binds to the iron in cytochrome C oxidase, the enzyme that lets your cells use oxygen. It shuts down cellular respiration faster than cyanide. But vent microbes either run entirely different metabolic pathways or they have evolved enzymes that oxidize the sulfide before it can interfere. They essentially eat the poison. This is where the implication becomes enormous. If life can evolve to thrive inside what is chemically a near-perfect killing machine, then the definition of a habitable zone in the universe just exploded. Europa, one of Jupiter's moons, almost certainly has hydrothermal vents on the floor of its subsurface ocean. Enceladus, orbiting Saturn, is actively venting water vapor from its interior, and that vapor contains silica particles that only form when liquid water contacts rock at temperatures above 90 degrees Celsius. We have already detected molecular hydrogen in that plume, which is exactly what vent-based microbes on Earth use as an energy source. The chemistry that would dissolve you is also the chemistry that might be sustaining life right now, 200 million kilometers away, in a dark ocean beneath an icy moon we have never visited. So what does surviving a hydrothermal vent actually require? A body built from scratch. Proteins redesigned at the amino acid level. A metabolism that runs on sulfur chemistry instead of oxygen. A cell membrane made from ether-linked lipids instead of the ester-linked ones your cells use, because ester bonds hydrolyze at high temperatures and ether bonds do not. You would need to be rebuilt from the molecular level up, and what you would become would no longer be human. It would be something closer to the first life that ever existed on this planet. The vent does not just destroy you. It shows you what you came from. If that idea, that the environment that would dissolve you is the environment that originally built life, is something you want more of, hit subscribe. Next time we are going inside the chemistry of tardigrades surviving the vacuum of space. The universe keeps doing things that should be impossible, and we are going to keep explaining exactly how.